In this video, we will continue to look at exponent rules. And the first one on deck is the quotient rule. So quotient is another word for divide. So when we have a division problem where you're looking at the same base, what we are going to do is actually subtract the exponents. Now, the other thing to keep in mind, because this is a division problem, when you have coefficients in front of your variables, we still want to divide the coefficients. And then you would use your quotient rule where we are going to keep the base, and in this example it's an x, and then subtract your exponents. And in this example that would be a minus b. So in example 1, we have 9x to the 6th being divided by 3x to the 2nd. And the first thing I'm going to highlight are those coefficients. And remember, we want to divide the 9 and the 3. And for the next part, we are going to subtract exponents on our like bases. So in this case, x to the 6th and x to the 2nd, they both have the x as their base. And when you subtract your exponents, please take the number on top, so that was the 6, and then subtract the number in the bottom, the 2. So for our final answer, we still have the coefficient of 3, and then we're going to have a base of x, but when I subtract my exponents, my final answer would be an x to the 4th. So 3x to the 4th is the answer for number 1. Let's look at one more example using the quotient rule. Now, example 2 has a few additional things going on. Notice the multiple variables. There's an x and a y. I'm also noticing there are some coefficients. So the 40 and the 15 out in front are going to be our coefficients that we want to divide. And then I'll also just highlight the x terms. So we'll be subtracting exponents on the base x. And we're going to take it one step further. We're going to be subtracting the exponents on our base y. So let's start with dividing the coefficients. Now when I look at 15 dividing into 40, I know 15 doesn't go into 40 an equal amount of times, but I can at least reduce that. If I think of it as a fraction, 40 over 15, I can reduce that down to 8 over 3. Okay, so both of those numbers are divisible by 5. Then I'm going to look at my x, and remember we're subtracting those exponents, so we're thinking about 12 minus 4. And same thing with the y. I'm thinking about 14 minus 7, so we're subtracting the exponents. Notice I'm taking the numerator, the top exponent, and then I'm subtracting the exponent in the denominator. So for a final answer, I'm going to write this as a giant fraction, so I have the 8/3, and then my x is going to go on top, and because we started with the top number, the 12, and I'm subtracting 4, that's how I know that I'm going to put my x answer in the top as well. And for the exponent, 12 minus 4 is 8. Now same thing with the y, I'm going to put the y term in the numerator, because I started with the numerator. I started with 14 and subtracted 7. So my exponent on the y should be a 7. So this is my final answer for number 2. In this slide, we will look at what happens when you raise something to the 0 power. And the rule is when you raise something to the 0 power, the answer is 1. So anything to the 0 power, whether it's a variable or a number, will equal 1. So for example, number 1, x to the 0 power, we would say equals 1. We can expand that topic to example 2, where we have the quantity 3x to the 3rd, y to the 4th, but notice that is all being raised to the 0 power. So the same idea applies where our answer is just 1. So no matter how simple or how complex the problem is, if your quantity is raised to the 0 power, it will result in an answer of 1. Now, example 3 brings up a common mistake. So let's take a look at this problem. We have 8 times the quantity 3x raised to the 0. You're probably tempted to say the answer is 1 and moving on. But when we look closely, the quantity 3x raised to the 0 is what's equal to 1. What we have still is 8 then being multiplied by 1. So we actually have a final answer of 8 for this example. So make sure your quantity being raised to the 0 is what you're writing down as 1. If there's anything additional that you might be multiplying by or adding on, it might affect your answer. Now our last rule for today will deal with negative exponents. And the rule of thumb is an answer is never simplified if it includes a negative exponent. So we need to figure out how to rewrite our answer with a positive exponent. And in order to do that, you can make a negative exponent positive by moving it and its base to the other side of the fraction. Okay, so a quick example, if we take a look at this x being raised to the negative a power, notice it's in the numerator, so it's in the top of the fraction, and then there's a arrow saying or showing that we are going to move it to the denominator. So in our final simplified answer, we don't have anything in the numerator, or we're going to use a 1 as a placeholder, but then that x to the negative a moved to the denominator, and notice it has a positive exponent. So we'll just kind of highlight that. Notice it's a positive a, whereas before in the numerator it was a negative a. The same thing can happen if you have, for example, the negative exponent could start off in the denominator. And we're going to want to then move that to the other side. So in this case, it would move to the numerator, and then it would produce a positive exponent. Okay, so we changed from a negative to a positive. And notice you could write this over 1 just to emphasize that our x to the a power is in the numerator, but you don't have to put that over 1. It would be understood that it's part of the numerator. So we've got a couple examples here. I know negative exponents are sometimes tricky, so we'll look at a couple different examples. And the first one starts us off with this x to the negative 9th power. Now the first thing I'm going to recommend is that you go ahead and put that over 1, just to emphasize what part of the fraction we're working with. So right now our x to the negative 9th power is in the numerator. And our rule says that we can take this entire quantity, so I'm going to take the base and the negative exponent, and I'm going to move that to the denominator. Okay, so we are going to move that. And remember, when you move, your negative exponent will become positive. So we have x to the positive 9th in the denominator. Now, since there's nothing else in the numerator, I do need to incorporate a 1 as a placeholder. And our final answer then is 1 over x to the 9th. Example 2 has a little bit more going on. Notice there are some coefficients. I see an x variable and a y variable. So notice the y variable has that negative exponent. We're going to take care of that first. That's going to be our first action plan, is to move anything with a negative exponent. We're going to move it to the other side. And in this case, it's in the denominator. So when I make that move, I'm going to move it to the numerator. So I'm going to go ahead and keep that 14, keep that x to the 7th, but notice the piece I'm moving, that y, and then because I'm moving it, it's going to have a positive 2 for the exponent. And I still have the 21 in the denominator. So all those other pieces didn't have a negative exponent. They didn't need to move. Only the part I have highlighted in orange made the move. Now from there, I'm looking at this as a final answer, and I think I can do just a little bit more. I can actually reduce my coefficients. Did you notice the coefficient, the 14 and the 21? Those are both divisible by 7. So I'm still going to have an answer with a fraction. And this time it's going to be a 2 over 3, because remember I'm dividing both the 14 and the 21 by 7. And then I have this x to the 7th and the y to the 2nd power on top in the numerator. All right, looking good. Final answer. So we have two more examples. Let's hop over to example 3 and check it out. So what is going on in example 3? Notice there is not just one negative exponent that will need to be moved, but there is a second part with a negative exponent that will need to be moved. So I'm actually going to be making two moves. The first move, that y to the negative 7th, I'm going to move from the numerator to the denominator. And then by making the move, I'll get a positive 7 for the exponent. Now that x to the negative 3rd will move from the denominator up to the top in the numerator, and notice the exponent will become a positive 3. So this answer is looking good. I'm going to box that as a final answer. Notice we have two positive exponents. We're good to go. And finally, example 4. We have x to the 9th being multiplied by x to the negative 7th. What I'm going to suggest is that you put that over 1 so we can see the numerator versus the denominator. And then I'm going to highlight this negative exponent. So we want to always move and take care of those negative exponents first. So I'm going to move that from the numerator to the denominator. So notice the x to the 9th will stay in the numerator. It did not have a negative exponent. The part that did have the negative exponent, we're going to move. So the x to the negative 7th will move to the denominator and become x to the positive 7th power. Now before I circle this for a final answer, I'm noticing that we actually have the same base. So I can subtract the exponents. Remember, our quotient rule tells me that I can subtract exponents on the same. So I'm going to write this as x, and I'm going to actually subtract the 9 minus 7, or let's end up with a final answer of x to the 2nd power. All right, so that is the most simplified best answer for example 4. Thanks for reviewing exponent rules with me today.